Hello guys, and welcome back to chemistry class. And of course, in this episode, we're going to be looking at properties of acids, and bases. All right, so I'm going to be looking into their physical properties and their chemical properties. Do you know that this video tutorial, of course, is brought to you by the O3SCHOOLS JAMB CBT practice app. It is the best app that you need to succeed in your exam. It has all the past questions for all subjects. There's a study mode, there's a practice mode, there's a mock mode, right, that you can use to prepare for your exam. Also, there's a UTME challenge where you can compete to win prizes with other JAMBites taking the exam with you. In that weekly UTME challenge, you are seeing your score after the challenge. You are seeing your score per subject. Then you are able to gauge your preparedness for the exam. You'll be able to see your weaknesses and be able to see your strengths, and you'll be able to work on your weaknesses. So please do not play with this app. Jump on it right now, download it, and start practicing. All right, now I'm going to look into the properties of acids and bases. So let's start with acids. Let's look at their physical properties. Let's look at the physical properties of acids, those ones that you can see that are glaring. All right, so number one, acids have sour tastes. Acids have sour tastes. Acids have sour taste. Just like unripe fruits, right? If you're watching this video right now, there's a very, very high probability that you have tasted an unripe fruit before, right? Either while far back when you're in primary school or secondary school, you're going home, you saw a mango tree, right? Because the ripe ones are at the top. You can just jump and plug for the unripe one, and you tasted it, right? You see that sour taste. So what's a physical property of acid, right? You are tasting an acid, all right, from that mango fruit, right? It may even be orange, an unripe orange that you have tasted before, right? So the sour taste, of course, is just like the taste for acid. Acids have a sour taste, just like those unripe fruits of that time. Number two, acids turn blue litmus paper red, right? So this is another property of acids. They turn blue litmus paper to red. So when they come in contact, once a blue litmus paper comes in contact with an acid, it immediately turns it to red. All right, I'm sure you have done those experiments in your secondary school before. All right, now number three, they have a sticky feel or texture. All right, so once you touch them, they have a sticky feel, and it sticks to your hand, right? It sticks, right? So they have a sticky feel or texture. And of course, number three, so that will be number four. Concentrated forms of acids are very corrosive. All right, so concentrated forms of acids that are very, very, very corrosive. In fact, they can even cause burn. They can cause burns. All right, so it can burn you. It can burn your skin once it comes in contact with it, right? So once your skin comes in contact, it can just burn you. So that's concentrated acids. So these are some of the physical properties of acid. Number one, acid have sour taste, just like unripe fruit. Number two, they turn blue litmus paper to red, right? So number three, they have a sticky feel or texture. And number four, concentrated forms of acids are very corrosive. That is, they can cause They can cause burns. Now let's see the chemical properties of acids. And before we see chemical properties of acids, make sure that you have liked this video, right? There's a like button just below this video like this. Just click on it, right? Liking the video will make other students like you to find this video easily, right? And of course, you can also subscribe. Subscription is free for this channel. So just click on that red subscribe button. And then, of course, whenever we publish any new video, right, you will get a notification on your phone that O3 Schools has published a new video. Please take advantage of these buttons and do the needful. All right, now let's look at that will be the chemical properties now of acids. Chemical properties. All right, now number one, they liberate hydrogen gas when reacted with metals. Now, once an acid reacts with metals, once acid reacts with metals, they liberate hydrogen gas. That means hydrogen gas is liberated when acids react with metals. Let's see an example. Of course, if you have an acid like HCl reacting with with a metal like magnesium, right? We're going to have MgCl2 then plus plus hydrogen gas, right? So this is what I'm talking about. This is HCl plus Mg. Mg is a metal. This is is an acid, right? Reacting to give a salt, right? MgCl2 and hydrogen gas is is liberated. So of course, if you see this equation, is it balanced? It's not balanced, obviously, right? Because there's 2 Cl here, there's just 1 Cl. You have to make sure that your equations are always balanced, right? There's Cl2 here, right? There's just 1 Cl here. H is 2 here, H is 1 here. So what will just happen is to put 2 here. If you put 2 here, there will be 2H, there will be 2 Cl. That means 2H is balanced, Cl is is balanced, Mg is 1 here, is 1 here. So it is the balanced equation. All right, number 2, they react with carbonate to liberate CO2. Number 2, they liberate CO2 when reacted with triisocarbonates. All right, so when they react with triisocarbonates, they liberate They liberate CO2, right? Let's see an example now. All right, so if you see for example, HCl reacting with a triisocarbonate 5 like Na2CO3, right? What you're going to have is this. This is NaCl. We're going to form NaCl will be formed. NaCl, that is the salt. NaCl will be formed. Then, of course, then plus CO2 will be liberated. Then plus water. All right. So this is the reaction. So when acid react with triisocarbonate, triisocarbonate, right? They liberate CO2. Right, this is the reaction, like you see hydrochloric acid reacting with Na2CO3, getting NaCl plus CO2 plus H2O. Now, you have to check, is the equation balanced? Is it balanced really? Look at there's 2 Na here. Yeah, there's just 1 Na here. All right, that means Na is not balanced. So that means putting 2 here will do us good. So we have Na2 here, Na2 here. Na is balanced, right? Na is balanced. Let's start with H first of all to start with. H is 1 here. H is 1 here, but H is 2 here. That means we need to put a 2 here. If you put a 2 here, that means there's 2H here, there's 2H here. That means H is balanced, isn't it? Now, is Cl balanced? Let's check for Cl. This Cl here, this is there's 2 Cl here, there's 2 Cl here, 2 Cl. This 2 is affecting both the H and the Cl. That means Cl is balanced here. Now, Na, we have balanced Na already. Is carbon balanced? Carbon, is it balanced? We have Yes, it's balanced. Just 1 carbon here. Right? It's oxygen balanced. Let's see oxygen. There's 1 oxygen here. There's 2 here. 2 plus 1 is 3. So you see that the equation is very, very balanced. Now, number 3. Let's see chemical properties of acid. They react with bases. They react with bases or alkalis to produce salt and water as the only product. All right, so they react with bases or alkalis to produce salt and water as the only product. Let's see an example. This is, let's say, H2SO4 reacting with NaOH So this will give us what? Once H2SO4 reacting with NaOH, I'm going to have Na2SO4, right? To produce what now? This is salt and what? Water. All right. So this will be the reaction. All right. Now this is H2SO4 plus NaOH. NaOH is a base. H2SO4 is an acid. So they are reacting together. You are giving a salt. This is salt of sodium and what? And water. Now check whether it's balanced. Is it balanced? There's 2 Na here. Okay, let's start with H. H is 2 here plus 1, 3. H is 3 here. H is 2 here. That means H is not balanced. All right. H is not balanced. That means there need to be what? Another up to something over there. But let's leave that first for now. There's Na2 here. Na is 1 here. So first of all, I need to balance that Na. If I have 2 here, that means there's 2 Na here, right? There's 2 Na here. Na is balanced. Now, H itself, there's what? 2H here already. There's 2H here. Then there's 2H here. 2H plus 2H is 4H. That means there's 4H on this left-hand side. How many H is here? Just what? Just 2. So we have to put 2 here. If we put 2 here now, it means that what? There's 4H here. There's 4H here. This 2H and this 2H. H is balanced. Na is balanced. Is S balanced? S is 1 here. S is 1 here. S is balanced. Now oxygen will be the main one to balance. All right. Now let's see. There's how many oxygen here? There's 2 oxygen here, right? 2 plus that's 2 of oxygen. 2 O is here. Then 4 O is here. 2 plus 4 is 6. How many O do we have here? Right? We have 4 here. Then we have 2 here. 2 plus 4 is 6. So oxygen is balanced. So this equation is already what? Balanced. So these are the chemical properties of what? Of acid. They liberate hydrogen gas when reacted with what? With metal. So hydrogen gas is liberated when what? Acid reacts with what? With metals. That is G. All right. Now, 2. They liberate CO2 when reacted with trials of carbonates. Right. So I'm going to have 2HCl plus what? Na2CO3 having 2 NaCl plus CO2 plus H2O. Now, of course, number 3, they react with bases or alkalis to produce salt and water as the only product. That is what? H2SO4 plus what? 2 NaOH, giving what? Na2SO4 plus 2. Another example you can do is what? You can react ACl plus what? CaO. This will give us CaCl2 plus H2O, right? CO is an alkali, right? So ACl reacting with CaO, I'm going to have CaCl2, right? Salt and what? And water. Is it balanced? I have to check whether it's balanced. There's 1 Ca here, there's 1 Ca here. Ca seems to be balanced. H is not balanced here because there's 2H here, there's just only 1 H here. So we need to put 1, 2 here. If you put 2 here, 2H now, 2H balance. Cl, is it balanced? There's 1 Cl, there's 2 Cl here already, 2 Cl. There's 2 Cl. Cl is balanced. What is left? Ca. Ca is 1, 1 is balanced. Oxygen. Is oxygen balanced here? Check if oxygen is balanced here. There's 1 oxygen here and there's 1 oxygen here. So oxygen is balanced also. All right, so these are the chemical properties of what? Of acids. Now, let's look at the physical properties of bases. Physical properties of bases. Please, if you have not liked this video, do like it immediately. Click on that like button below this video. And please click on the subscribe button so that you can get notifications once we publish a new video. And download the O3SCHOOLS JAMB app right away and start practicing. Activation is just 3,000 naira as opposed to 2,500 naira that it was sold the previous year, right? So cost of things are going up, and of course it will keep going up. This country will find ourselves, but we have to keep moving on. All right, now let's continue. Let's see basis now. Basis. Now let's see the physical properties. Physical properties of bases. Now, number 1, we said acids have what? A sour taste, like on ripe fruit, right? Bases, on the other hand, bases have a bitter taste. They have what? A bitter taste. For example, let's say NaOH. NaOH has a very, very bitter taste. That's a very bitter taste, right? So bases have what? A bitter taste. Once you test them, right, they are very what? They are very bitter. Then number 2, bases turn red litmus paper blue, right? So they turn red litmus paper to what? To blue. Let me write it to blue. to blue. All right, so once a base comes in contact with a red litmus paper, it turns it to a blue, showing what is basic property. All right, so they turn red litmus paper blue. Acid turns blue to red, right? Bases turn red to blue. All right, so number 3, remember we said acid have what? Sticky feel. In this case, they have bases have a slippery or soapy feel or texture. All right, so bases have a slippery or soapy or feel or texture. Also, concentrated what? Solutions of bases, concentrated bases are very corrosive. Concentrated forms of bases are what? Very, very what? Corrosive. So these are the physical properties. If you know the physical properties of acid, you already know you cannot use your Carnot to know what the physical properties of what? Of bases. They are almost like opposites, right? Now, except that they have the same property. Their concentrated forms are corrosive, both of them. All right, now let's see the chemical properties of bases. Right, let's see the chemical properties of bases, and we're done with this class. All right, please do not forget to like the video once again. Click on the like button. There are tutorials for all subjects on this channel. Right, anyone that's not here now is definitely going to be worked on. All right, so please. Look, just search for O3 schools on YouTube generally. So you see, go to videos, you see all our videos, right? Both for you will see for all subjects: chemistry, physics, mathematics, economics, biology. They are all going to be there. All right, now let's see physical properties of bases. Then number 1. One of the very, very important properties are what? They react with acid to form salt and water, right? Bases react with acids to produce salt and water only. All right. So the reaction between what a base and an acid to produce what? Salt and water. Bases react with acid to produce what? Salt and water. Let's see an example. A base like NaOH, a base like NaOH reacting with what? NaCl. So what are you going to have? Very common reaction. NaCl plus what? Plus H2O. Very simple. Right? This is HCl. Is it balanced? There's 2 H here. There's 1 Na here. 1 Cl here. O is 1 here. So it is very, very well balanced. Right? Then again, they react with what? With metals to produce hydrogen gas. Number 2. They also react with metals to liberate hydrogen gas. But please, the difference between this and acid, between bases and acid, is that acid reacts with what? With metal to liberate hydrogen gas. But bases react with what? Metals to also liberate hydrogen gas. But it is very, very specific. The reaction is very specific to some elements. But this is specific to tin and other elements above it in the electrochemical series. All right. So now bases also liberate hydrogen gas when they react with metals, but it is common, it is specific, it is special, right? For what? For tin and other elements that are above tin, like zinc in the periodic table. So, for example, if you have Zn reacting now with what? A base like what? NaOH in the presence of what? Of water, H2O. All right. So this will now give us what? Na 2ZnOH4 plus H2. All right. So this will be what? The reaction. And Zn plus NaOH plus H2O plus, it will give us what? Na2ZnOH plus what now? Plus H2. Is it balanced? You have to check. You have to check. So if you put 2 here, I think that equation would be what? Will be balanced. So they react with what? With metals to liberate hydrogen gas, but it is usually what? Specific to what? To tin and other elements that are above it in the periodic table. Then lastly, they also react with what? With they liberate what? Ammonia. They react with what? Ammonium salt to liberate what? Ammonia. Number 3, they liberate ammonia from ammonium salts. All right. So, for example, if a base like NaOH is reacting with an ammonium salt like NH4Cl, right? The what? Liberate what? Ammonia. I'm going to have NH3. Okay, first of all, I'm going to have NaCl, then plus what now? NH3 plus H2O. All right. So they liberate what? Ammonia from ammonium salt, from a solution of what? Of their salt, right? From solution of ammonium salt. So NH4Cl is ammonium salt here. Reacting with what? A base like NaOH. So you see what? NaCl is formed plus what? NH3 and H2O. The equation balance, I think it is balanced. So you can check it out. All right. So these are what? The chemical properties of what? Sorry, these are chemical properties now of bases. Chemical. These are the chemical properties of what? Of bases. Now that we have seen acids and bases, we have seen their properties, their physical and chemical properties. In the next class, we'll take another what? Part of what? Acid, bases, and salt. And of course, I would like to see you in that class. Stay tuned. Thanks for watching.